So first of all, I want to thank everybody for taking time out of their busy schedules to participate in this webinar. Over the years, we've had some very, very, very good feedback. It's actually kind of interesting because Howard does give so much technical information that usually it's hard to digest in one sitting. So a lot of times we'll see the same people come back and view over a course of time, view the webinar multiple times to be able to glean different pieces of information off of the presentation. For those of you who don't know me, my name is Jason Spangler. I am the flooring division manager here at Wagner Meters. I'm responsible for not only the Rapid RH and the concrete moisture testing side of things, but I'm also responsible for the small line of hand meters that we have for testing the moisture content in wood and wood subfloors. Speaking of the standard, if you will, of itself, one of the things I'll tell you right now, you guys are going to be the first ones to hear about it. As of yesterday, the ASTM F2170 standard, which dictates how to do in situ relative humidity testing, which includes devices like the Rapid RH, has decreased its amount of time necessary to have a legitimate moisture reading. So the ASTM before yesterday was 72 hours. It has decreased now to 24 hours. So to be clear, you can drill the hole, you can vacuum it out and get it prepared. You can put a Rapid RH sensor in there, leave it for the 24 hours, come back and get a reading, and that is a legitimate reading for you to make an installation decision based off of. So brand new as of yesterday, so hot off the presses. You can get the new standard at astm.org. We're going to do a Q&A session here. I'll get to as many of the questions as possible. If, for whatever reason, I don't get to your question, please don't hesitate to give me a call directly. My phone number is 800-634-9961, and it's extension 235. I would say keep the number because, again, if you come up with something down the road, we're always available, and that's what we're here for, is to be able to try to help you with any of the issues that you might have. So the first question that I have comes from Thomas. Thomas asks if I will, or if we will, address how this test can be used on older slabs that have recently been affected by water damage. I'm not 100% sure, Thomas, on exactly what it is that you're looking for here, because the device is still going to be used in the same fashion, whether we're talking about flood damage or otherwise. Depending on how long the moisture has been on the surface of the concrete, that's where the difference might come into play as to whether or not the water has in the time frame that you're doing testing, whether that high level of relative humidity or moisture from the surface has made it down to that 40% depth. But I have numerous people on the remediation side of things that use, or restoration side of things, that use these sensors to be able to look at the drying of the concrete after an issue. The one thing I will say is that it's interesting the difference in thought processes of what the insurance industry looks at slabs being dry after we'll just say a situation occurs, versus how the flooring industry looks at a floor being dry. They really have two different definitions for dry, and it's interesting to sit there and listen to people that have to play on both sides of the fence, because it's hard to be able to justify an installation with information that you use to justify whether a slab has dried out after an episode with an insurance company. Another question from Thomas. He says, I just bought the Rapid RH 5.0 system, which, for those of you who aren't familiar with, we have a 4.0 system and we have a 5.0 system. We're the only company on the market that actually offers you choices. You have a choice of either using a single usage product like the Rapid RH 4.0 or a reusable product like the Rapid RH 5.0. If you're going to use a reusable system, the 5.0 is going to be the easiest, most efficient system for you to use. The question is, do you want to spend your time using a reusable system, having to go through the process of verification of calibration every 30 days, having to send the sensor in once a year to have it rebuilt. Some people, that's how they want to, that's how they have their business model, and they're fine with the additional time that it takes and the additional detail they need to pay to a reusable system. So to answer your question, it's not the fact that you did or didn't make a mistake. It's just the fact that the choice was there. So if you're okay using or spending the extra time to use a reusable system, then the 5.0 is a great option. For a lot of people, it's not what they think is their best option or their best usage of time, and so they either go to or stick with the RapidRH 4.0. A couple of questions that I get on a consistent basis. One is, we talk about the relative humidity testing being a very depth-specific measurement, and people will ask the question as to, how do I know how thick the slab is? So a lot of times I'll tell people, if you're not familiar with or not used to going onto a job site and needing to know the thickness of a slab, you'd be surprised at how many different things are transpiring in an active work environment, whether it's remodel or new construction, where you can physically see or determine thickness. For instance, talking new construction, you have building documents, you have job site superintendents. Depending on how early you're on the job, you're able to see the actual concrete being poured. Some of the situations where the building hasn't been backfilled, you can kind of get kind of an idea of what the concrete looks like at that point. Elevated slabs in a pan deck, a lot of times if you have penetration through that pan decking on an elevated slab, it's not a tight fit, so you can see around there's access to be able to see what the profile of the pan decking and the thickness of the concrete is around those penetrations. Stairwells, when you're looking at remodel, a lot of remodel stuff, they retrench or they have to trench to move plumbing, things along those lines. Again, I always tell people, you'd be surprised at how many different things are going on that will allow you to determine that. Now, worst case scenario, what I'm seeing people do out in the marketplace, or what I'm seeing them talk to me about, is that worst case scenario, they'll take a smaller diameter drill bit, they'll drill into the slab in a couple of spots. It's not something where you want to run around and make the slab into Swiss cheese. But you drill into a couple spots, they take a piece of pliable wire and they make a J-hook out of it. They push it down in that hole until it comes out the bottom. The J kind of springs out a little bit, and they pull it up until they feel tension. They'll take a Sharpie and mark it at the surface of the concrete, pull it all the way out. You can see where the mark's at, and then you can see where the radius for that J-hook is, and get a fairly good idea. By doing it in two varying areas of the slab, at least you get some comparative information, and you've done your due diligence at that point to be able to determine thickness. Is it going to be absolute? No, but it's going to be something that's definitely going to help you. Another option is they do make a device. The device is, I don't know the exact specs, but I want to say it was within plus or minus a half of an inch as far as being able to determine thickness. You can use it. It works off of what they call echo impact principle. So it's something that's put on the surface. It scans down through, rebounds to the device on the concrete, and gives you that close approximation. The downside to it is about $2,500 last time I checked. So it just depends. When you're talking about elevated pan deck, I get the question about where's the placement on an elevated pan deck. You have highs and the lows and the corrugation, and you end up with a situation where the question always comes out, do I do 40% of the thinnest portion or 40% of the thickest portion? So the first thing I tell people is, ASTM committee, the standard, is absolutely 100% silent on their stance either way on that. So that's the technical side of it. On the other side of it, the way we recommend it is that you try to determine where that thickest portion of that pan is, and that's where we want you to test at 40%. So if it's, say, 2.5 inches in the thinnest, 6 inches in the deepest, we want you to identify where that 6-inch area is and drill 40% into that deepest area. So then the question is, how do I find that? They make some fairly inexpensive metal detectors that work a lot like stud finders in walls for determining where wood studs are. You can put them on the surface of the concrete. You can scan through. They'll pick up the high points of the pan decking, but not the low points. And you can mark on center where those high points are at. It's not going to be absolute, I can tell you that, because rebar can interfere with it. There can be some other things that there can be an issue. But that's one way that people do it. They make a more expensive meter that's about $700. They're both made by Bosch. That tends to work pretty well, but again, it's still not going to be absolute because of the other additional things like the rebar that are in there. I'll also find that people sometimes in that situation will take a, again, smaller diameter drill bit, and they may try to drill multiple holes to determine where they're at in that pan decking. And then once they find that deepest section, they'll just mark on center where those deepest areas are at. I have another question here that says, is there a non-destructive method for determining whether a slab has a vapor barrier, or really correctly, does it have a vapor retarder? Not that I'm aware of. The most common practice for how to determine that is going to be a core sample. And there's a lot of people out there that are really big into core samples because they look at it as the fact that sometimes with core samples, if there's not a vapor retarder or a vapor barrier, you can have fluctuations in the moisture conditions of the concrete. All right, it looks like that's all the questions that I have. Again, my name is Jason Spangler. Phone number is 800-634-9961. It's extension 235. And I'm going to leave you with this one again. If you didn't catch the first part, the standard as of yesterday changed in respect to relative humidity testing. And you can now drill clean holes, insert sensors, and have absolute numbers within 24 hours, as opposed to the old situation, which was 72 hours. So you have now saved 48 hours by using relative humidity testing. Thanks, and have a great day.